So why do we care about significant figures? Well, oftentimes when we're measuring things in a lab or doing a science experiment, we have to do calculations with numbers. So let's do an example problem. And let's say we measure an object and it has a mass of 8.2 grams. We also find out that this object has a volume of 1.03 milliliters. Now, one thing we may want to do with this is determine its density, which is mass divided by volume. So when we do this, we'll do this problem out, and we get 8.2 divided by 1.03. And when we do that math out, we get 7.96116.505 grams per milliliter. Now, this number has a lot of decimal places, and you may have heard you have to round to a certain number of places, but you've never heard really why. And the reason for this is, well, let's look at our measurements. Our first measurement here, 8.2 grams, is only good to two significant figures. We only measure to the tenth of the gram. Our volume measurement, it's a little more precise, measures to the hundredth of a milliliter. But when we do the math, we end up with all these decimal places at the end. It's impossible to know that these numbers are correct at the end here. All we know is information about the tenths place and information about the hundredths place. So how do we deal with this problem? How do we get a number, an answer that has the correct number of significant figures? So again, we have some rules that guide us into getting the correct number of significant figures in our answer. So rule number 1 is for multiplication and division. So whenever you do a multiplication or division calculation, the answer has the same number of significant figures as the original number that has the fewest significant figures. So let's look at our original example problem. Since we did division, it would fall under this rule number 1. So we have our first number in the calculation, 8.2 grams, as we said, has two significant figures. While our volume, 1.03, because the 0 is sandwiched between two non-zero numbers, has three significant figures. Now we look and see, well, which one has the fewest? Well, 2 is smaller than 3, so we're going to use 2 as the number of significant figures in our answer. So we look at our answer, and we're going to find the first significant number reading left to right. So the first significant number is 7, and then we want two significant figures. So our second significant figure would be 9, and we round to that number. So 6, it's a 6 here, meaning we have to round up, and our answer with two significant figures becomes 8.0 grams per milliliter. Again, not forgetting the unit. Let's look at one more problem using multiplication and division. So if we have two measurements that we want to multiply, such as 4.23 times 1.5, we get 6.345. Now we have to figure out the correct number of significant figures. If we look at the first number here, 4.23, there are 3 significant figures. If we look at our second number, 1.5, there are 2 significant figures. What this tells us is our answer needs to be rounded to 2 significant figures. So we count, here's our first significant figure, here's our second significant figure. We look at the one past that, it's a 4, meaning the number stays the same. And our answer is going to be 6.3, which has 2 significant figures. Our second rule for significant figures is for addition and subtraction. Whenever we have an addition or subtraction calculation, the answer has the same number of decimal places as the original number with the fewest number of decimal places. Let's look at an example. So if I have the numbers 7.56, which has 3 significant figures, plus 8.2569, which has 5 significant figures, and I need to figure out the answer. So if I add those together normally, I would end up with 15.8169 as my answer. Now, we have to follow the rules for adding and subtracting with significant figures. So we look at the number of decimal points, decimal places only, in order to figure this out. Do not count the total number of significant figures. So we look in this number here, and we see that in the first number, 7.56, we have 2 decimal places. In our second addend, we have 4 decimal places. What this means is we take the lower number and it tells us that our answer should only have 2 decimal places. So we're going to round to the second decimal place, which has a 1 right there. And because the number after this 1 is a 6, we're going to have to round up. And that will give us a final answer of 15.82 as our answer. And note that this has 2 decimal places. And that's it for significant figures.